Welcome again, dear grade 9 students. And after we talked about expanding factors, I guess we are going to make a lot of training exercises to be more smart in expanding factors and to be more familiar with them. And now we are going to talk about factorization. And after finishing these ideas, we are going to make training exercises to make things clearer and easier. Factorization of polynomials. I guess you have an idea about factorization of polynomials since grade 7. And this idea starts by factorizing polynomials by taking common factors, as you see here. In the first example, you have an expanded form. So all what you have to do is to factorize, which means to write as a product. Notice I'm telling you that you are going to write as a product of factors. Let's see what this means. I have x squared y cubed minus 3x power 4 y to the power 5 plus 2x squared y squared. So the first idea of taking common factors is to search for like the GCD of the numbers. So I don't have here a common number to be taken outside. I have 3 here and I have 2, no relation between them, and I have here 1. So I can't take any GCD for 3 and 2 because they are actually relatively prime and their GCD is 1, as you know. So I search for common factors concerning letters and powers. What are the common letters here? I have x, y here, I have xy here also, and here also I have xy. So the letters I'm going to take as common factors are x and y, so I have to search now for the least power. I have x squared, I have x to the power 4, and I have x squared again, so I take x squared as a common factor. Going to y, I have y cubed, I have y to the power 5, and I have y squared. So again, I'm going to take y squared as a common factor. Then I have x squared, y squared as common factors. Now, what should I do? I have to divide each one of these monomials by the common factor taken outside. So x squared y cubed divided by x squared y squared. X squared will cancel x squared, as if I'm putting it like this, over x squared y squared. So x squared will cancel x squared, and y cubed over y squared. If you refer to powers, all what I have to do is to subtract these powers, and I will get y power 3 minus 2, which is y power 1, as you see here. So x squared will cancel x squared, and y cubed power 3 minus 2 is power 1. So I subtract the powers or the exponents. Let's continue. I continue dividing minus 3x power 4 y to the power 5 by x squared y squared. Of course, my 3 is kept. X power 4 divided by x squared, I just subtract the exponents. 4 minus 2 is 2, then x squared is kept inside. And y to the power 5 divided by y squared is just subtracting the exponents because I have the same base y. So I will get y to the power 3. So as if we are making a revision for division of powers. And finally, 2x squared y squared divided by x squared y squared. X squared will cancel x squared, y squared will cancel y squared, and what remains is just 2. And by this, we changed from the expanded form into a product of two factors, because here there is like a factor multiplied by another factor indeed. So this is what we mean by factorization, is changing from the expanded form into a product of factors. They may be 2 or more. Now let's move to the second example. We have 14x squared y cubed minus 7x to the power 4 y to the power 5 21 x squared y squared. So as I told you before, we have to search for a GCD that divides all these numbers together, or these coefficients. So all what I have to do is to search among 14, 7, and 21 for a GCD that divides them at the same time. Then it is 7, of course. 7 divides 14 and divides 21, so I take 7 as a common number. Now let's think about taking the common letters and searching for the least power for each letter. I have x squared y cubed, I have x power 4 y5, I have x squared y squared. So obviously the common factors or the common letters that are going to be taken are x and y. The least power of x among these three givens is x power 2, and the least power of 2 of y is also 2. So I will take 7 as a common number among these three numbers. I will take x squared and y squared, and I will start division. 14 by 7 is 2. X squared will cancel x squared, and y cubed divided by y squared is y to the power 1 by subtracting the exponents. Again, minus is kept. 7 divided by 7 will be cancelled, it's 1. X to the power 4 divided by x squared is x squared, and y to the power 5 by y squared is y cubed because I subtract the exponents again. Finally, 21 divided by 7 is 3. X squared by x squared will be cancelled, y squared and y squared will be cancelled, and thus I will get only 3. Here is another example on taking common factors, but here I'm going to take a factor between parentheses. I have 6 into x minus 1 all of it squared minus 3 into x minus 1 multiplied by x plus 2. So as you notice, I search for a GCD among these numbers. I have 6 and 3, so surely I'm going to take 3. And now here I have x minus 1, and here I have x minus 1. So I take x minus 1 as a common factor also. So I take 3 as a common number and x minus 1 as a common factor. So notice, this is one block separated by a minus, and this is the second block. So I search for commons among these blocks, okay? So this is alone and this is alone, and I search for the commons among these. Now I will get 3 outside as I told you, and x minus 1. What happens inside? Let's see what happens inside. We have again to divide 6x minus 1 squared by 3 into x minus 1. So as if I'm putting it over, okay, as if I'm putting over 3 into x minus 1. So 6 by 3 is 2, as you see here, and x minus 1 squared by x minus 1 is x minus 1. Okay, so you will have 6x minus 1 squared when divided by 3 into x minus 1 will give me 2 into x minus 1. Now let's move to the second block. Minus 3 divided by 3 is minus 1, and x minus 1 will cancel x minus 1, and just x plus 2 remains inside. So again, if I put over 3 into x minus 1, because I'm going to divide by the common factor taken, 3 will cancel 3, and x minus 1 will cancel x minus 1. What remains is minus into x plus 2, as you see here. And finally, I have to carry out the value inside the brackets. So I will get 3 into x minus 1 outside, and here I will get 2x minus 2. So I have 2x minus 2, and I introduced the minus sign, so I will get minus x and minus 2, and finally I can add 2x with minus x to get x, and minus 2 with minus 2 is minus 4, and by this I get a product of 3 factors. The first one is 3, The second factor is x minus 1, and the third factor is x minus 4. And by this, I changed the expanded form into a product of factors, and that's what we call by factorization. And here is the last example about taking common factors, about factorization by taking common factors. I have 5 into x minus 2 squared minus this. So this is a block, as I told you, and this is another block. They are separated by a minus sign. So 5 into x minus 2 squared minus 10 into x minus 1 and into 2 minus x. So this looks like this one, but all what I have to do is to reverse the terms. I have to make it x minus 2, and to make such thing, all what I have to do is to change the sign that precedes it. Now let's search for a common number among the numbers. I have 5 and I have 10, so I can take 5 as a common number. Now after organizing this one, I have 5 into x minus 2 squared plus 10 into x minus 1 into x minus 2. So note please, 2 minus x is reversed into x minus 2, but the sign must be changed here. If it is minus, it becomes plus. If it is plus, it becomes minus. So whenever you are reversing two terms separated by a minus in the middle, you have to change the sign that precedes the factor, all this term, all this block. Now I have to take 5 as a common number between 5 and 10, and I have to take x minus 2 as a common factor among these two. So we have 5x minus 2 outside. I start dividing 5x minus 2 squared by 5x minus 2. Then 5 will cancel 5. X minus 2 squared will be simplified by x minus 2 to get only x minus 2. Now 10 divided by 5 is 2. X minus 1 is kept, and x minus 2 is going to be simplified by x minus 2. And thus inside I get x minus 2 plus 2x minus 2. So I have x minus 2 plus 2x minus 2. Now adding these, reducing them, I have to get 3x minus 4. So finally I will have the factorized form in the form of a product of three factors that are 5x minus 2 and 3x minus 4. So 3x minus 4 comes from adding x and 2x, which gives 3x, minus 2 and minus 2, which gives minus 4. So this is about factorization by taking common factors. Now let's talk about factorization by using identities. So the identities I told you about were a plus b squared. That's equal, let's recall, it's equal to a squared, remember with me, plus 2ab plus b squared. Now you are going to have in this form, in the expanded form, and you are going to determine this factorized form. So you have it in the expanded form as you see here, 4x squared plus 4x plus 1. So you just look at the extremities, 4x squared and 1, and we put square for 1 because 1 squared is the same as 1. And we just make the radical of the first term and the last term. So what's the radical of 4x squared? It is 2x. What's the radical of 1 squared? It is 1. And in the middle we put the same sign in the middle. Now what about this 4x in the middle? This is to make sure if this identity is true or not, if it works or not. How to make sure? All what you have to do is to multiply 2 from the rule 2 in your mind by the first term and by the second term, then 2 into 2x into 1, then it's definitely 4x, which is true as you have here in the middle. So how to know what identity you have to use? If you have 3 terms, then you have to think of this identity, whether plus or minus. It depends on the sign in the middle. If it is a plus, then you put plus. If it is minus, then you put minus. So you just take the extremities, which are 4x squared. You take the radical of 4x squared and the radical of 1 squared, because 1 squared and 1 are the same. And the radical of 4x squared is put here, the radical of the second one is put here, and you put the same sign you have in the middle. Then you make sure if multiplying these two terms by each other and then by 2 will give the same result in the middle. Let's continue to apply the identity on this example. We have 49x squared minus 42x plus 9. Keep this alone and let's think of these two. 49x squared comes from 7x. 9 comes from 3. So as if I'm making the radical of 49x squared. The radical of 49x squared is 7x. The radical of 9 is 3. And I put minus between them because there is minus sign in the middle. Now let's make sure if this identity, if this factorization using the identity is true. So all what I have to do is to multiply the first term 7x by 3, it's 21x, by 2 in my mind using the rule here, it is 42x, which is true. And finally here is factorization using the last identity, which is the difference between two squares, which is a minus b into a plus b, that gives into a plus b, that gives a squared minus b squared. Let's apply it. I have only 2 terms. I apply it when I have 2 terms separated by a minus sign, just a minus sign. So 2 terms separated by a minus sign will let me think of this identity. 3 terms will let me think of this identity. Now the radical of 49x squared is 7x and the radical of 9 is 3. So all what I have to do is to open 2 parentheses. In the first one I put 7x minus 3. I make the radical for this and for this. And in this second factor or parenthesis I put 7x plus 3. If you are going to make sure, you can just expand these and definitely you are going to get 49x squared minus 9. Now, this is a remark. To determine the roots after factorization, sometimes they ask us to find the roots, to factorize and then to find the roots. So all what we have to do is to solve that the factors are equal to 0. For example, here if you have x squared minus 9 equals to 0, we can't solve unless we factorize. So x minus 3 into x plus 3 equals 0, then x equals to 3. We solve each one alone as if solving x minus 3 equals to 0. So x minus 3 equals to 0 will definitely give x equals 3. And x plus 3 equals to 0. X plus 3 equals to 0 will give that x equals to minus 3. And these are what we call the roots of this equation. So all what we have to do to find the roots is to factorize and then to solve each one alone equals to 0.